Good morning, class. We're ready to do some surface area of prisms today. We've already worked on these a little bit with our daily math review, so this should be a little bit of review for you. So we'll go a little bit faster than normal on lessons. So Kelly wants to cover her shoebox with the decorative paper without overlapping the paper. How much paper will she need? Surface area, remember, is to cover the entire outside. So you need the surface area of, or the area of each side of your shape. So being that we have 6 faces on this, we have 3 pairs that are identical. Remember we talked about if you find the area of the top, we would double that area to include the bottom of the package, which would be the same. So when we find the area of the front side of our box, we'll double it to cover the area that's on the back side of the box. And the same thing with the right side of the box, we'll find the area and double it to cover the left side of the box. So our formula is shown down below here, so you can use that as a reference. That times 2 is what we were talking about when we cover our top and our bottom are both the same. So when we look at, let's look at our top first, our dimensions, length times width. So we have 10 times 8, which gives us 80. And we double it because we're doing the top and the bottom, which are the same size. So that gives us 160. That's our first dimension to add into our bottom here. So let's go with the front side next. Our front side dimensions are still 8 for our length, but our width is 6. So 8 times 6 equals 48. And then we double it because we also have the back side of our box, which gives us the same dimensions. So there's our 96. We'll add that in our formula at the bottom. Plus one more pair of sides. The right side has a length of 10 and a width of 6. So we take our 10 times 6, which gives us 60. And we double it because the right side is also the same dimensions, which gives us 120. So now we add those all up. And it looks like that gives us 376 square inches, or inches squared. So that's an example number 1 for you to keep in your notes so that if you run into trouble with any of these others, you can look back at how we solved each one of them. So we're going to move ahead to the next one. You turn to our next slide. This one is showing the net of the shape. So you see once we flatten it out, our net shows all 6 of our surfaces. Okay, so we're back doing our dimensions. If we start on the top, we have a 4 of a length and 2 as a width. So 4 times 2 gives us 8. And the top is the same dimensions as the bottom, so we double it. That gives us 16. So we'll start with 16 down here. Now, when we look at the front side, we have a length of 4 and a width of 3. So we take our 4 times our 3, that gives us 12. And since the front is the same dimensions as the back, we can double that, which gives us 24. And our final one would be the right side area. So we have a length of 2 and a width of 3. So 3 times 2 gives us 6, and the right side will be the same dimensions as the left side, so we double it. That gives us 12. So once we add all those up, that gives us 52 centimeters square area. So again, here's our formula you can use as a reference if you need to. And it doesn't matter which order we multiply those in because multiplication can be mixed around with that commutative property. So let's try one more and then I'll have you practice a little bit. Okay, so we went ahead to that fourth card to look at the formula for a cube, which remember a cube has all sides are the same. So you notice our length is 7, our width is 7, and our height is 7. So you can simplify that formula a little bit to say surface area is 6 times the sides squared. So when we look at each side, we're going to take 7 times 7. That's where we get the s squared because the sides are the same. So when we take one side, which is 7 times 7, that would be a side length of 7 squared. That's 49. So each of our 6 faces are going to be 49 square centimeters. So that's why we can simplify this equation and just take it times 6 because the front and the back and the top and the bottom and the right and the left are all going to be the same dimensions of 49 square centimeters. So when we multiply our 9 times 6, we get 54, and 6 times 4 is 24, plus 5 more would be 29. So when we have a cube and all sides are the same, we can just square two of the lengths, which are identical. 7 squared is 49, and then times our 6 sides, and you're finished right away. So that's the only change that can simplify it a little bit for you when you get to it. So the last one we're going to look at, it has some triangles in it. So if you turn to slide 5, okay, our last one we're going to look at is the surface area of the triangular prism. So you notice our formulas are going to change a little bit because we have two triangles in our shape. So remembering that our area of a triangle is the base times the height divided by 2. We'll also use the area of a rectangular shape as our length times width. So those two will need in combination when we deconstruct the triangular prism. So we can start with our two triangles because they are opposites. So they're going to have the same dimensions. So like we did on our first rectangular prisms, we can double it once we find that triangle. So we take our base times our height. The base is 12 here. The height is 9. So 12 times 9 gives us 108. And then we divide that by 2 because it's a triangle. But since we have two triangles, what we do to find the area of one triangle is to divide it by 2. But since then we would turn around and multiply it by 2 because we have two of the same shape and size, we can just keep our dimensions of 108. That would cover the area of both triangles together. So then we look at our net that shows us we have 3 rectangles, but the width of those rectangles are not the same. One is 15, one is 12, and one is 9. But our length for all of those are 18. So we can start on this front one, taking our 18 times 15, which would give us 270. We don't have to divide that by 2 because we only do that when it's a triangle, and this is our rectangle that we found the area of first. So our second one has a width of 12. So this time we'll take our length of 18 times 12, which would give us 216. And our final length is 9. So our final rectangle right here would be 18 for a length times 9. So 18 times 9 would give us 162. So our last step, remember, is to go back through and add up all of those individual pieces that we deconstructed our shape into. So if you remember, we had an area of 108 for our two triangles, 270, 216, 162, which gives us a total of 756 centimeters squared. Oops, sorry about that. Let's try squaring that again. Because it is area, so all of your units will be square units. So that's some of them broken down. Make sure you look at the formulas when you have triangles in your shapes that you flatten out, and when you have a cube where all sides are the same. You can simplify that a little bit. So be sure when you look back over these, you use them to help you, because the ones that you're going to try are exactly the same. So you're going to finish by doing the last 5 in this series and resubmit those back into Canvas when you're done. So Friday we'll look at those and see how you did. Hopefully you have a good first day of e-learning. We've got this, so I'll see you Friday.